Hello participants, I welcome to lecture 24. Lecture 24 is on drip irrigation, design consideration and system layout. In lecture 23, we discussed about drip irrigation system. We learnt about different components of drip irrigation system. Now, having learned about the different components of drip irrigation system, once we are interested to use this system, install the system in the field, we should have prior information, we should design the system, we should be hydraulically efficient, it should be economical, and then find out the suitable layout as per the field requirement. So, in this lecture we are going to cover the points needed for planning of drip irrigation system. After knowing the information available, having the resource inventory done, then we will take up what are the general points which are needed for designing a drip irrigation system, weighting pattern, percent weighted area by a particular type of drip emitter or set of group of drip emitters, how to determine crop water requirement and finalizing the layout of drip system. When we talk of design and drip irrigation system design, our aim is to achieve higher irrigation efficiency, means we are interested to get high emission uniformity from the drip emitters, and this is only possible when our system is perfectly hydraulically designed and the drippers are properly chosen, they are free from any problems related to clogging, then only we can achieve high emission uniformity. Our aim is to maintain optimum soil moisture level for optimal crop yield. So, it should not over irrigate, it should not under irrigate. So, moisture content is very important parameter which will help for the plant growth, and ultimately it will result in getting the high crop yield. To keep both initial state investment and annual cost at minimum level. This is a very important thing when we are deciding a particular design and layout. So, we have to see that the investment means there should be minimum attachment within the system, and also see that energy cost which is a annual cost which is matter. So, if it is a properly designed, we will be getting the annual cost reduced. So, we should aim for this point also. The other point is to design suitable type of system which will last long, and also for the longer time period, life period of the system, it should perform at a high efficiency, it should perform well. The other point is to design a manageable system which can be easily operated and maintained. Yes, design should be user friendly. Anybody who wants to use it, then it can be properly, system can be operated and easily maintained. This is for any design, not only for drip system, but this should be easily operated and maintained, then only it is a efficient design. To satisfy and fulfill the need of crops. Yes, design should meet the crop water requirement, it should meet the fertigation requirement, means it should have the adequate capacity of the pump, adequate capacity of the fertigation unit, adequate capacity of the all other systems which have been used as the components. And then also finally, it helps to fulfill the requirement of the user, crop grower or farmers. Now, what are the different steps one should follow when we are taking the design of micro irrigation system. So, the first most thing is that one should make the inventory of resources. What are the resources? Means what is the type of soil, what is the land elevation, what is the source of water, whether source of water is adequate, what is the quality of water. So, these are some of the, it comes under the resource inventory, and then we should collect those data, analyze them carefully, that will become an input when we are taking design. Computation of peak water requirement. Computation of peak water requirement, if we are able to get the water requirement of the crop during peak season, peak demand, or during summer month when we are considering, means our system design is conservative design which will take care of all season. When crop is at initial stage, when it is in maturity stage, when it is a late season stage. So, peak design will take care of that. Deciding the appropriate layout of the system, this is in the topic we will discuss about that, what should be the appropriate layout one should follow. Then choosing drip emitters. So, having got the type of soil, having got the particular type of crop, then we will choose appropriate emitter and its a capacity. Hydraulic design of the system in terms of lateral, means design for lateral, design for sub-main, design for main pipeline, and then finally, we will estimate what is the total pressure requirement, what will be the total water requirement, then we will get the horsepower requirement of the pump. Now, going little detail about the inventory of the resources and data collection, means we need to have the scaled plan site, means map of the place, that is the location map where the irrigation area is to be crop is to be irrigated. So, what is the area it is there, and then what is the topography, elevation, what is the highest elevation in the field, because that will be needed while we are finding out the head requirement. Irrigation water source, is it a surface water or ground water? Then what is the whether the quantity of water which is available, is it adequate to meet the requirement, because this we will be considering for that period when crop is in the peak growth stage, means peak requirement. So, whether that much water will be available. So, one is that peak water requirement on daily basis, then total water requirement for the whole season, and that has to be, and then what is the quality of water, how much is the sand, silt and clay, and then the other the anion, cation, which are there in the water, can it be separated, that should be analyzed before we are thinking of a drip irrigation system. Soil type means is a texture, what type of soil it is there, accordingly we will choose the particular type of emitter. Local climatic data, weather data, it is important. So, weather data analysis will be we discussed about crop evapotranspiration. So, the basic fundamental part of this course regarding estimation of evapotranspiration requirement of the crop, reference evapotranspiration, this already I have discussed. So, that will be needed using the data. And then this we in the previous slide I was telling you peak water requirement, ET0 daily it is needed for operating the system, but ET0 particularly during peak season or during summer month, maybe for some crops it will be needed. Then the proposed planting, what type of the crop, then is a plant means, and then what is the spacing between the crop, what is the type of crop, and then what is the means your maturity stage of the crop. So, all these are to be needed. Then as I told you that the quality of water. So, quality of water we will need that what is the type of filter will be needing, whether 2 filters are adequate, 1 filter itself is adequate, or all 3-4 types of filter will be needed, that will be decided based on the quality of water available. And it is then if I am taking a filter, it should give high filtration efficiency, it should not get clogged, there should be minimum the head loss due to filter elements. So, we will take care of the chemical quality of water, what is the means filtration means this secondary safety about the screening. Then the other part is your pressure variation, pressure due to the, as I told you that about the filter pressure variation due to elevation in the field. So, and then what is the operating pressure which is needed, so that the particular emission device that is to be used that can be operated, degree of control or pressure, this is another component that should be taken care. And then one should know the discharge pressure relationship, means when we are considering what is the discharge needed, how much pressure it is needing. So, accordingly a hydrant will be placed in a means your line should be connected with the source of water, so that it is delivering appropriate discharge. And then we should have a provision to monitor the flow rate, we should have provision to monitor the pressure at different points. The another point which I was telling you in previous class about the weighting system, weighting by a dripper means it forms a onion shape or it forms a elliptical shape. So, that is the weighting pattern, what type of weighting it forms when the water is being supplied by a dripper. So, it will depend, means the water will weight in horizontal or in vertical direction. So, you can see here when water is being given by a one point source drip emitter, the horizontal spread of water is more as compared to the vertical spread of water. This happens when water is being given with the dripper in clay soil. In loam soil, the shape the volume of water is same which has been given, but it has taken a different shape. When you come to the sandy soil, the vertical movement of water is more as compared to the horizontal movement. So, this kind of situation it happens when we are considering a particular type of dripper. So, we will work out the weighting pattern. Now, weighting pattern we will estimate in terms of percent weighted area. Now, percentage weighted area compared to the entire cropped area depends on the volume, rate of discharge at each emission point, spacing of emission point and type of soil. I would say that it is the soil, it is the particular type of dripper and the time of application of water, that will be important while the horizontal as well as vertical movement of water from the point source emitter, when the water is movement it takes place. So, P w is P w is determined from an estimate of average area weighted at a depth of 15 to 30 centimeter beneath the emitter, that is divided by the total cropped area served. So, we can see here system having high P w provide more storage of water, means that will be the thing that that how much is the P w percentage wetting area provide more for the more storage of water. So, for wide spacing crops P w should be between a practical value I am telling you 30% to 70%. Now, 30% what I am telling, this is when the for horticultural crop when it is in the initial growth stage, and it goes to 70% when it is in the fully grown. So, when we are designing the system, one should take about 60 to 70% in that range, this should be taken. It is given below 67% to keep strip below rows between dry and cultural practice. Now, low P w reduces the loss of water, it is correct. If we lesser will be the wetting, means there will be lesser means loss, there will be low evaporation will be low, and the means even water where the water covers are cover crops are used. Now, it is costly to have low P w for more emitters and tubing. When we need to have more P w when we want to. So, then what will happen? We will be using drippers, this your tubings where the inline type of drippers are used. So, that one complete strip can be made. So, closely spaced crop with rows and emitter laterals less than 1.8 meter, the percentage weighted area approaches to 0. Means when the close spacing crop we are considering, say vegetable crop, their weighting is maintained as 100%, and on sloping land weighting pattern may be distorted due to effect of the slope. Now, we want to find out how to get the value of P w, that is the percent weighting area. So, this can be estimated by means the N p, that is your number of emitters per tree multiplied by the spacing of emitters in the lateral multiplied by the weighting width divided by the SP, that is the spacing plant spacing, and SR is the spacing between the rows. So, this way one can find out for the single lateral system. Now, when we are finding out the particularly for micro sprinkler or for spray types of emitter, then one can find out the percentage weighting is number of the points, that is your the number of emitters per tree into AP, that is your the surface soil surface area directly weighted by sprayers plus the spacing of emitters multiplied by the perimeter of area directly weighted by sprayers divided by 2, and then the whole thing it is divided by the product of plant to plant and row to row spacing. So, this will give for when we are considering the spray system or micro sprinkler system waiting area one can calculate. This is a study which has been reported by James in 1998. That maximum diameter of weighted circle that is formed by single emitter device when it is discharging about 4 liter per hour for various soils. You can see here, if it is a coarse soil, it is a homogeneous coarse soil, the water movement is 45 centimeter. In case of varying layers, it is weighting bulb is of 75 centimeter diameter, and when it is the varying layers generally having medium density 110 centimeter. So, as we go for the varying layers, means it is a layered kind of a system, it is exists when there is a medium density soil it exists. What we find that the weighting bulb or weighting diameter AW it is more as compared to the other area. So, this is the way it is estimated, and you can see how a typical when the means there are two laterals which are spaced, and then the how the a particular drip emitter it is discharging the. So, we need to here what we are seeing, this is the spacing between the drip lateral. So, we need to see that there is a proper overlap of this weighting bulb which has been found by the drip emitter. So, that the effective root zone depth of the plant is irrigated. Now, computing the irrigation water requirement, as we have learnt in the previous same concept, it is used here also. Irrigation water requirement is the amount of water in addition to the rainfall must be applied to meet the crop water evapotranspiration without reduction in the yield. So, crop water requirement under drip irrigation system it will vary with the different crops. Under surface and sprinkler irrigation, primarily the land area weighted is reduced, resulting in less evaporation from soil surface. So, the peak water requirement we can give here Q equal to E T naught, that is the reference evapotranspiration in millimeter per day multiplied by the crop coefficient K C multiplied by the area under each plant, that is the spacing between the plant multiplied by the spacing between the rows of these plants multiplied by the percent weighted area. Same thing, it is a PW. It is PW, it is the area of each individual plant, and this is the ETC. This we have studied ETC. This ET naught into Kc is actual crop evapotranspiration. So, this way now ET naught is though it is written here, it is a reference evapotranspiration, but we need to get the ET naught value for peak requirement when there is a high demand of atmosphere, it is there, that will cause the more ET naught values, means temperature, solar radiation, wind they are active, then only ET naught means the crop is also it is that particular crop which will be there is no shortage of moisture, and then it is at the full growth stage. Now, when we want to find out the capacity of drip irrigation system, so it is necessary to determine the system capacity, operating time per season to design a pumping plant and pipeline network that are economical and efficient. According to Keller and Blissner in 1990, they have given this expression to estimate the capacity of drip irrigation system. Capacity of drip irrigation system is nothing but the total quantity of water or discharge to be supplied by the pump. So, it is given by area of the field multiplied by the discharge of a particular emitter multiplied by the number of, here it is given that means number of operating hours multiplied by the row to row spacing, that is the spacing between the plant, and then SL is the spacing between the lateral. So, we will get the value of this area, how much area is to be irrigated, this plant means particular area between the means the in the of the each individual plant, and then total area, and the discharge is known divided by the operating hours, then one can know that what will be the discharge. So, this will give the total system capacity. So, now here time of operation is another component. Time of operation means how many hours the system should be operated. So, having got we know the volume of water supply, what is needed, that volume we will get based on the what number of plants and its ET naught value, means area multiplied by the ET naught multiplied by the number of plant, that will give the this thing. So, and then that is divided by the Q. So, this will give us the total time of operation of the drip system. Now, capacity of the drip system can be verified from the means can be estimated by using this thing, that flow carried by the lateral is the discharge of one emitter multiplied by the number of drippers or emitters in each lateral. Flow carried by the main pipeline, sub main pipeline is the number of laterals in each sub main pipeline multiplied by discharge of one lateral. So, this is QL is multiplied by the number of laterals. Similarly, the discharge carried by the main pipeline is the discharge of one sub main manifold multiplied by the number of sub main pipeline. Now, each drip irrigation system should be can be laid in different ways depending on the source of water supply, depending on the field layout. So, it is possible to apply water to the whole field by drip system method at same time as far as possible. Of course, it will, if the area is very large, one can divide the area into number of zones, but if for a smaller area one can give water at it all the points. So, this is the way that when it is given, water is being brought from the source of supply, main is laid just parallel to the width, and then directly on the main lateral pipeline has been attached. So, this is one kind of layout when your area is a small area where sub mains are not used. This could be the another way that when area is having, so main pipeline is brought up to the means your from the width of the means center of the pipeline, and then on either side lateral pipelines which has been attached. This is also possible when the area is small. We did not have a sub main pipeline. So, field needs to be divided into number of the sub mains. So, that could be a different arrangement. Here what we are seeing, that main pipeline is laid and then sub main pipelines has been attached. So, we can divide depending on how much is the width and then total number of plants and what is the total area it is there. So, this is one kind of arrangement which we are seeing that. So, layout will depend upon the field requirement and layout of the field. So, each subunit is then designed separately and operated operated separately, having wall at the head of subunit. So, when I am telling about that, what say this is the one case, what happened, the main pipeline, it comes to the center and then sub main pipeline, and from this sub main pipeline laterals have been attached. So, here there are two sub main, one sub main line goes this side, another sub main line goes this side, and for in each this sub main line there is a gate wall attached. So, system layout will depend upon the shape of the field, area of the field, source of water supply. That is, now if everything is open to us and then the well has to be dug. So, it is better that the source of water supply it should be in the middle of the field. So, that the cost of bringing water and attaching main pipeline can be reduced. Now, number of sub main can be decided. This is one criteria, that total time available for irrigation divided by the time of operation of the drip system. So, we got the time of operation of the drip system, but total time available will depend upon the number of electricity available in the region. This is another point, that the number of hours when the electricity available, accordingly one has to see, and accordingly the number of subunits, number of walls that can be operated. Layout of the drip system, that is the arrangement of main, sub main, lateral is done considering the shape of the field. This already I have told you, size of the field and slope, that which direction the main should run, which direction lateral should run. So, as far as possible sub main should run along the slope of the field and lateral should be laid across the slope or along the contour line of the field. So, you can see here this is the arrangement, it is shown here. There is one lateral means there, and then the in between these the crop rows are being grown. So, here we see that lateral line are kept between the rows of the plant. You can see here that according to the rows of the plant, each independent one line per row it goes adjacent to the rows, these laterals are laid. So, this will happen upon depending on the plant water requirement and then field arrangement. This is the another case, there are two lines per row, means when the plant is aged, water requirement is high. In that case, for orchard crop, perennial crop, where the water requirement is high, we can have two lines of the lateral for each row. This is one arrangement. The other one is we are seeing it in between the two rows, one lateral goes. So, this kind of arrangement it is used. So, we can see here a dripper is attached with the lateral. Here these are the drippers, and then in between the two rows, these are the two rows, there is one lateral it goes. So, these two rows there is one lateral goes. This is the type of arrangement with and then this is means one dripper per plant, and then paired row can be there. Two drippers per plant means water requirement is very high, or there can be 4 drippers for each plant, where the another tube is attached with the main lateral, means your lateral pipeline of 16 millimeter. Then there is a connector, from this connector the 10 millimeter or 12 millimeter lateral is attached, and that make circular, and then irrigation is being given. So, laterals are to be laid as per the plant configuration, field configuration that can be made. So, here same thing which I have explained, this is given, again it is repeated once the field layout is finalized, diameter, length of sub main pipeline, laterals for each units are decided based on the hydraulic design of the pipeline. Spacing between the lateral depends on the crop geometry and row crops. For plantation or orchard crop, spacing between lateral is equal to the row spacing. However, depending on the age of the tree, tree spacing and soil type, 2 laterals per row of tree may be needed. This is what I was telling you, this kind of a thing it will happen particularly for orchard crop, which is of aged, its water requirement is high. The spacing between the emitter on lateral for row crops is governed by soil type, where case of plantation or tree crops, number of emitters per tree is governed by the spacing, age, soil type. And also one thing I want to tell here, that yes, it is the emitter is important, but when it is a very too close crop, then simply giving one dripper or two dripper, it is better to use micro sprinkler, so that the wetting can be made for particularly for close growing crops. So, we discussed all these topics. Now, you can have the closer detail, more details about on this particular topic by referring these books. This is a very important book which we can have. Then you can have Larry G. James book, Michael A.M. book. So, these books you can refer for more details. So, let us summarize this particular lecture. We discussed about the points which are used for the design of drip irrigation system, what should be the points which should be considered for while we are designing the system. We discussed about wetting pattern, and so wetting pattern, it depends on the particular different types of soil, and then amount of water which is being discharging from a emitter, and then time of application, crop water requirement and system layout also we discussed. Now, in forthcoming lecture we will discuss about the different types of drip emitters and how to select a particular type of drip emitter. So, thank you very much